Good day, guys. So today we are looking at a state of matter. This is Mrs. Tole. So we must understand that all matter is made up of separate particles, and this can be seen in diffusion and Brownian motion. So we must understand that diffusion is when the movement of your particles from region of higher concentration to a region of lower concentration. This is a very important a process that we must understand. Diffusion can be seen when you place the food drop in the coloring in water, or the colors, you find that the color slowly spreads out in what call in the water. That's what we call diffusion. Or if you spray perfume on one corner of the room, you find that in a matter of seconds or a matter of minutes, you actually smell the perfume in the whole room. That's what we call a diffusion. Now, Brownian motion is a random movement of microscopic particles of substance due to their collision with the particles of surrounding air and surrounding liquid. Now, we must understand that matter can only exist as a form of solid, liquid, or gas. Okay. Now, when you look at solids, they've got a fixed shape. So they've got a fixed shape and volume. Liquid takes the shape of the container. Like if you put water in the container, it follows the shape of the container. But gas, they are free, they are everywhere in the container. So they just fill the container that is in it. So that's what gases do. Then matter can change between these states. So you find that solid can change to liquid, also to to gas. What you call through change in what call in temperatures. So if you have to change the temperatures of on the solid, you'll find that it will it will melt to liquid, and if you increase the temperature again, it will actually boil and evaporate. Okay, so we're going to talk of changes of what you call of matter, changes of matter from one state to another state. Now, as we look at melting point, this is the temperature at which your solid changes into what called into a liquid, and we call this melting. Like if you take an ice, the ice blocks, if you put them even on the table, you find that with both of the temperatures they're high, they actually start to melt into what you call liquid. Okay, so on our next page, we check, we see that there's a freezing point. Now, freezing point is the temperature at which the liquid now goes back to the solid. So liquid changing to solid, that's what we call the freezing point. Then the boiling point is where your liquid is changing to gas. So that's the temperature that we. So boiling point, we are referring to the temperature at which it changes to gas. Now, this process, we call it what? Evaporation. Okay. Then we go on to condensation, is a process of going from gas to liquid, and you've got sublimation, process of solid to gas. So I think you know that those guys that are selling ice cream, if you check those ice cubes that are used, that are in the what you call cooler boxes and everything, you find that that ice, you never see liquid inside. You only see the ice, and when the ice is just finishing, what happened there is what we call sublimation. It's changing from solid to gas, and the reverse of sublimation is actually deposition, which is the from gas to solid, directly to solid. There is no liquid phase there. So, for example, very good example for is carbon dioxide. So the ice of carbon dioxide. So that's what you see there. Carbon dioxide, it changes from solid to actually to gas. Then deposition is the process going from gas to solid, and the reverse like is sublimation. Then this is just a table for you to understand that deposition and what you call in sublimation here, sublimation going this way and deposition going this way, gas to solid. And we just want to elaborate here through what we call the heating curve and the cooling curve. So the heating curve is actually changing, showing you the changes, what happens when you have to take that ice cube from what we call even the ice. If you take it and what we call increase what we call the heat, and maybe increase the heat on the ice, you find that you turn to the liquid, and from there to turn to gas. So you must understand very well the heating curve. So we're going to start with the heating curve, and what you see there is that we have got ice here. And when we have ice here, the ice will melt. So here, what happens here, we call this the melting point. So melting point. So melting point, you find that the temperature, it remains constant here. The temperature remains constant. This is because the heat energy goes into breaking or the bonds of the what you call that's what we have in what we call on the water. So it goes into separating what you call those water molecules. So that's what happens. That's why we find that the heat remains what you call it remains constant here. So we have got from there, it melt and give us what you call water. So this one here, not water as such, but liquid. Liquid. Then from there, we have the liquid phase here. Then in this case now, what do we have now? We're going to go on to what you call to the gas, what you call where it's turning from what you call liquid to gas. So this one we call it what you call boiling point. So here what we have got a mixture here. We have got ice at melting point. We have got ice plus liquid. That's what you always must remember. We have got two states here. We've got ice mixed with what you call with liquid, and here we have got a solid mixed with gas. That's why you see when you're boiling in water in a pot, you find that you open the pot and you see steam there. When you see that steam, but there's still liquid there, that's what we're talking about there. So here we've got liquid. So you must always understand that there we have got liquid plus your gas. So until it completely turns into liquid, that's when the temperature will actually begin to change. Okay, then we come back to what we go to what call to cooling curve. The cooling curve is just showing you what happens when you reduce the temperatures. So here now we are saying we have got here. We are going to start now from this point here. We are seeing that we have we are starting from the the temperature is high here. We are cooling it. So what we have here, we have got gas here. And we have got what? We have got gas here. Then we cool the temperature. When we cool the temperature, it turns into what? Into liquid. And when it turns to liquid, here now, we continue to freeze. This one, we call this the freezing what? Freezing point. Now, on the freezing point, that's where you find that it's turning your water. We've got ice. You've got ice plus your liquid. And what do we have here? From there, we'll form what we call ice. So it completely form ice there. That's what we have at the end. Okay. So that's what we must understand when we talk of what we call the heating curve and the cooling curve. So we are starting here. We are going from ice until the gas phase. Then here we're starting from the gas phase. We are cooling it, and when we cool it, we form what we call the liquid. And when we form the liquid, we form what we call it goes to what it goes to the freezing point. Okay. Now, so here we can say now, just labeling it condensation, like what we know, condensation. We are returning a gas to what? To liquid. So we must understand this very well. Condensation, here we're having our freezing point. Now, let's go to the next point. Next slide. Now, here is showing us how the particles are arranged in each state. So we find that in solid, the particles are packed closely. They are densely packed. They are packed closely, close to each other. Then in the liquid, they are further apart. They are actually far away from each other, but not that far, but they are far apart. They are now, there is now space between them. So here we don't find much space between them, but here we've got a space between them. Then from there, as we increase the temperature, I find that those particles actually start to move further apart, far away from each other. That's what we see in the gaseous phase. Okay, so this summarizes what actually in its phase, what we have in its phase. Then here, when we see that the temperature of substance is directly proportional to the average kinetic energy of particles. So as you increase the temperature here, the particles start to move. So here, the particles, they don't have energy. When you increase the temperature, you're giving the particles energy to move. So particles are starting to move, and actually they're having what we call kinetic energy, which is the moving energy. Then if the substance is heated, the particles gain more energy, move faster, and consequently their kinetic energy increases. At low temperature, these particles have got a lower average energy. Now, we have got state of matter. If particles gain enough energy, they will be able to to break the intermolecular force, because here we've got one molecule, and this one is another molecule. Let's say molecule or water molecules. So in this case here, we are going, if we increase the temperature will break the intermolecular forces, the forces. So it's actually loosening up the forces here, loosening up, and until actually they break, what call it breaks is what you call it breaks the forces between the intermolecular forces between them, breaks. That's what we refer to what call intermolecular forces between what call water molecules. So we've got water molecule here. Let's say we know that it's H2O. We have got O, what you call H2O, and it's connected to another what you call another H2O. Okay, so here what we have here is what called hydrogen bond. So it actually breaks with time. It actually breaks when you continue to increase the temperature. Then you have separate what called separate water molecules. That's what we're talking about. What you're seeing there in the what you call in the in the in the gaseous phase. Now, what we refer to as latent heat or hidden heat is the what is the energy absorbed or released during state change. So whenever we apply heat here, what is being applied, what is being absorbed there is what called latent heat that will change the state to what called to liquid phase. Okay. Then now on the last slide, we are looking at the what called properties of what called of matter. Now we are looking at the properties of matter, and we are saying here we have got, we're talking of energy in terms of when you talk of energy in terms of what called a solid what you call solid phase. In the solid phase, we know that there is less energy, and the particles here you find that they are having what called they are having more energy than the solid phase. Then here the particles are actually having more energy, high energy, and they are consequently constantly moving. Then the space between the particles, here you find that there is very little space here. The particles are tightly packed together, and here there are bigger spaces compared to the vertical solid. Then as you move to the gaseous phase, the space actually is actually large spaces between them. Then attraction forces between particles, you find that there is very strong forces here, very strong forces, because they are still pegged, the particles are still pegged together. Then as you move on to liquid, they are weak, the forces are being weakened. So they are weak forces on the what you call on the liquid. Then on the gaseous phase, they actually weak forces, and what you call because of the space that is between them. Then changes in phase, the solid becomes liquid. So as you continue to increase the temperature here, the what you call the solid becomes what you call changes to liquid, and as you increase the temperature again on the liquid, it will change to what to gaseous phase. And here there is no other vertical phase after after the gas, so it actually remains there in the gaseous phase until you have to reduce the temperature. Then it actually goes back to the liquid phase. Okay, so I hope you understand. I hope this was helpful. We'll also be having questions, what call it, to tackling questions together. So just to have a follow up on my lectures, then you actually be helped much. Okay, thank you so much.